This is the second video for section 5.1, which is mean value theorem, and we are on example 3. So example 3 says, find the equation of the tangent line. So we need a point and a slope to write an equation of a tangent line of this function on the interval 0 to pi at the point which is a solution to the mean value theorem. So we're going to first find the x value, or the c, that satisfies the mean value theorem, and then use that to write our equation of our tangent line. So mean value theorem is where derivative equals algebra 1 slope. So let's find both of those. So f prime of x, I'm going to make sure you can see that, okay? Okay, equals 2 plus cosine of x. And then, so that's our derivative. And now we need algebra 1 slope, which is going to be on this interval f of pi minus f of 0 over pi minus 0. Excuse me. So let's plug pi into our function. I'm trying to write small here. I'm hoping to fit it on that line. That would be 2 pi plus sine of pi plus 1. So that's f of pi minus f of 0. That would just be 0. So sine of 0 plus 1 all over pi minus 0. And I'll let you work that out, but you should get 2 for that. I'm trying to save space here. 2 pi is 2 pi. Sine of pi is -1, so those add to 0. So I end up with 2 pi. Sine of 0 is 0, minus 1. So I have 2 pi plus 1 minus 1 over pi. So the pi's divide to give you 1, and you're left with 2. Okay, so the point that satisfies MVT can be found by setting algebra 1 slope equal to derivative. So we're going to solve the equation 2 cosine of x equals 2. So, this is 2 plus cosine of x. So if I minus 2 from both sides, what I'm solving is cosine of x equals 0, and that is at x equals pi over 2. Remember, we're just interested in this interval. Okay, so x equals pi over 2. Now, I want to write an equation of a tangent line at x equals pi over 2. So I need slope and point. So slope will be f prime of pi over 2, which will be 2 plus cosine of pi over 2, which will just be 2. So that's my slope. And now I need my point, which will be plugging pi over 2 into my original function. So f of pi over 2 will be 2 times pi over 2 plus sine of pi over 2 plus 1. 2 times pi over 2 is just pi. Sine of pi over 2 is 1. So this equals pi plus 2. So my coordinate point is when x is pi over 2, y is pi plus 2. Okay, so let's write equation of a line. Line that satisfies mean value theorem is y minus y equals m times x minus x. And remember, you can leave it in point slope form. Yeah, that looks good. When they're telling you to find a solution that satisfies MVT, you can assume that MVT applies. They wouldn't ask you to do this if MVT applies. That's why I didn't start with saying that the function is continuous and differentiable. Okay, example 4. When does mean value theorem not apply? So think of the requirements for mean value theorem, continuous and differentiable. So when does it not apply? When either one of those things are violated. So when it doesn't apply is if the function is not continuous on the closed interval, or not differentiable, which I'm going to abbreviate, on the open interval. Try to squeeze that in up there. So that's what you want to be on the lookout for. Now, right away, when you see an absolute value, you should think, oh, this graph is going to have a corner at x equals 3. So then you would say MVT does not apply, does not apply, because f of x is not differentiable. Hate writing that word. At x equals 3. So be specific if you're saying that it doesn't apply. On 2-5, we should have double checked to make sure that corner was on the interval that they're asking us about, and it was. Okay, the B, if you look at a function like this, a rational, right away, you should recognize there's a vertical asymptote at x equals -2. And then check the, let's zoom in a little here, check the interval they're asking you about. -2 is on the interval. So again, MVT does not apply. And in this case, it's going to be, because it's not continuous, because it has that vertical asymptote. So because, I'm going to shorten that, g of x is not continuous at x equals -2. You could also say there's a vertical asymptote at x equals -2, but cannot use mean value theorem there. This graph was in your packet from the beginning of the year as one of those you want to memorize. This is what I call the seagull graph, right? This looks like how you would draw seagulls on your drawing when you were in elementary school. So it's got this cusp at x equals 0, which is in this interval. So x equals 0 is a cusp. So this one, MVT does not apply because it is not differentiable at x equals 0. Because h of x is not differentiable at x equals 0. Squeezing it in there. This would be a graph you're expected to have in your memory bank. This would be a no calculator. Actually, all of these would be no calculator. So those are graphs you should recognize. Okay, one more real-world application of the mean value theorem. So this one might be actually more writing than math, but I guess that's okay. 2 stationary police cars equipped with radar are 5 miles apart. Everything's kind of in the drawing here. So here's your 5 miles apart. As you drive your sports car, that's kind of a hint, as you drive your sports car past the first patrol car, your speed is 55 miles an hour. So that'd be right here. 4 minutes later, so 4 minutes has elapsed. You pass a second patrol car, which clocks you at 50 miles per hour. Is it possible you could be issued a citation for exceeding the posted 55 mile an hour speed limit? Show your analysis. So MVT says that average rate of change must equal instantaneous rate of change at some point on this interval. Okay, so MVT states average rate of change. Oh my gosh, totally spelled that so wrong. Average rate of change must equal instantaneous rate of change. I'm going to write ROC sometime on this interval. You can also assume a continuous function. The car is always driving on the road. So I'm going to say assume continuous function and differentiable. Okay. So MVT does apply. So we can think of average rate of change here as average velocity, and then this would be instantaneous rate of change would be instantaneous velocity. So average velocity, so this is like your algebra 1 slope, would be change in distance. So I'm going to say delta in distance, which we know is 5 miles, right, over change in time, delta time, which is 4 minutes. So you have gone 5 miles in 4 minutes. All right. Our speed limit is miles per hour. This is minutes, so let's convert this to hours because we're trying to see if we're over 55 miles per hour. So our minutes cancel and we end up with 75 miles per hour. So average rate of change says at some point during here, your speed was 75 miles per hour. So because average velocity is 75 miles per hour, you are likely traveling at more than 75 miles per hour at some moment, or you're likely traveling more than 55 miles per hour at some moment. So if average velocity is 75 miles per hour and the function is continuous, your instantaneous velocity would also be 75 miles per hour at some moment. That's what mean value theorem says, or I should say at some time. Therefore, you were speeding. Therefore, you were speeding. Okay, that's that wraps it up for mean value theorem.